Hi guys, and welcome to another video. Today's video lesson, we're continuing with factorization. So this is part 2 of a series of videos on factorization. So if you didn't watch the other one, go watch that one first and then come back and watch this one. If you look at what we've covered thus far, we've looked at highest common factor. And remember that we always look to remove a highest common factor as the first type of factorization, or the most common type of factorization. We always look to remove a highest common factor. Then we have difference of two squares, also covered in the previous video. And then we have a quadratic trinomial. Then number 4, we have grouping in pairs. So we'll just say grouping. And what I need to look at in this one is definitely sum and a difference. So sum and a difference of two cubes. Sum and difference of two cubes. Okay, so we looked at HCF, highest common factor, difference of two squares, where we have a perfect square minus a perfect square, quadratic trinomial, grouping in pairs, and we're going to be looking at sum and difference of two cubes. Now we may even cover all of these types of factorization in today's video lesson. So let's get straight into it. If you look carefully, look at the work schedule here, and this is KZN Department of Education, and this is the 2021 work schedule. So if you look very carefully, you can now see that we are here, factorization, and it says here to include types taught in grade 9 and trinomials, grouping in pairs, sum and difference of two cubes. So let's look at a recent past examination question, and right over here. So let's just look at there we go, algebra. And so if you look here, we've already covered, I think, the 2018 examination paper question 1. So let's look here at the what came out in the 2017 paper. Right, so it says factorize the following expressions fully, and then it says here that we have two examples here, right? So it says factorize, so only two examples here. Let's look at these two examples. Okay, so there we go, and yeah, you can see we got sum and difference of two cubes here. All right, so let's look at it. So let's just put it up here. Okay, so let's look at it. It says factorize the following expressions fully. So 1.2.1, 1.2.1, we got t squared into r minus s minus r plus s. So here, if you look carefully, we'll actually have to do grouping first here. So you have to group here first. You have to remove a minus sign here. So therefore, we're going to get t squared into r minus s minus into r minus s. Always check your factorization by products. If you take minus into the brackets, minus times r is minus r, minus times minus s is plus s. Now if you look carefully, learners, you can see that r minus s here now is a highest common factor, HCF. So first we grouped, so first we did grouping, right? And then we are removing r minus s as the highest common factor. So r minus s into t squared minus, and you'll be left with 1 there, right? T squared minus 1, because remember r minus s is your factor. So therefore, you now can see that t squared minus 1 is, see, there's difference of two squares. So in this one example here, you grouped first, then you remove the highest common factor, and then now you're going to do difference of two squares. So it's important for you to be able to identify all your types of factorization. So we've got r minus s and then difference of two squares. Remember, t squared is equal to t times t, and 1 is equal to 1 times 1. Therefore, we draw our two sets of brackets like so, and we'll say t times t is t squared, 1 times 1 is 1, and we'll say plus times minus will give me minus. So therefore, this is now fully factorized. Let's look at the next example. 1.2.2, x cubed plus 1 all over x squared minus x plus 1. Now, if you look very carefully, x cubed plus 1 is going to be sum and difference of 2 cubes, right? Because remember, x cubed is a perfect cube and 1 is also a perfect cube. So let's write that down. 1.2.2. We got x cubed plus 1, x cubed plus 1, all over x squared minus x plus 1. Now you'll notice that x squared minus x plus 1 cannot be factorized, okay? Remember that 1, now if you look at 1, 1 is only 1 times 1, which is, for example, to get positive 1 will be minus 1 and minus 1. And you can see clearly that we don't have negative 2 there. So this trinomial, if you want to call it that, yes you can, it's 3 terms, it can't be factorized. So therefore we got x cubed plus 1. So what we're going to do is we're going to say x cubed is x times x times x. So we're going to factorize it because x times x times x is x cubed and 1 is equal. So as I said, x cubed is x times x times x and 1 is 1 times 1 times 1. So we basically factorized x cubed and 1. So now if you look at it, remember that we're going to have in our first bracket a binomial and in the second bracket we're going to have a trinomial. Now we already said that we can't factorize x squared minus x plus 1 by inspection, that is. So we can only factorize the top. So therefore what we're going to do now, we'll say x and 1. So we'll write x and 1. Same sign, you copy it here, plus. Okay, so x plus 1. Then x times x is x squared, 1 times 1 plus 1. Okay, so now we are left to get the middle term. So the middle term is is derived as follows. You multiply these two terms here, x and plus 1, okay, which you will get positive x, and then you need to now change the sign and put it in here. So it will be minus x. So it's x squared minus x plus 1. Once again, to get your middle term, you multiply the two terms in your first bracket and change the sign. So x times plus 1 is plus x, change the sign, minus x. What do you notice? X squared minus x plus 1, x squared minus x plus 1. You can cancel that out. Therefore, you are left with x plus 1. You will be surprised how many times this is tested at matric level. X cubed plus 1. Because we hardly do it in grade 11. So I need you to remember this from now up until grade 12. So let's quickly recap what we've done. We've looked at this paper, which is the November 2017 paper 1, and we looked at this question here, where we covered now grouping, and we looked at, for example, let's go back to that question. We looked at grouping, highest common factor, difference of two squares. And then in the second question, we looked at sum and difference of two cubes, which is this one here. Sum and difference of two cubes, Okay, let's see if we can do one more question. Okay, so let's go and look at the following. So what are we left with here now? Let's see, what paper is this one up here? This is the November 2015 paper 1. Right, November 2015 paper 1, what is got here? X to the 4 minus 81, that's difference of two squares. This one here will be grouping, right? I think we skipped the question here. Let's see what we got here. What's this? November 2016. Right, removal of common factor there. And then we got grouping again. And this one is a quadratic trinomial. Okay, let's rather do this one over here. November 2016. There's 3 questions here. Okay, and then this will conclude now our questions on factorizing and factorization and so on. Okay, so November 2016. Let's check it out. November 2016. Right, so this will be, let's write over here, November 2016. Right, so yeah, let's see what we're going to do. 1.1.1. So for 1.1.1, you can see here that you can remove a highest common factor, which is x into x. X times x is x squared, and then x times minus 1 is minus x. So x into x minus 1. What did you do there? You removed the highest common factor. And then you can't factorize any further. Let's double check. X times x, x squared, x times minus 1 minus x. 1.1.2. So 1.1.2. 3x squared plus 3px minus 2mx minus 2mp. Right, so let's look at these first two terms here. What you got here? 3, 3, and then you can take out an x and x there. Second two terms, you got 2 and 2, you got m and m. So you can remove, see, grouping in pairs. So if you look at these first two terms here, you got 3, and you can take out x into. So 3x into, what's this? X, 3x times x is 3x squared. And what you'll be left with over here? 3x times, so it will be plus p. 3x times plus p is plus 3px. So yeah, let's take out minus, what we can take out here? 2m minus 2m. What will be left with here? X. Minus 2m times x is minus 2mx. And minus 2m times plus p will give us minus 2mp. So therefore now if you look at it, let's double check. Minus 2m times x is minus 2mx. Minus 2m times plus p is minus 2mp. 3x times x is 3x squared. 3x times plus p is plus 3px. So now if you look carefully, you can now take out this x plus p. You can remove it as a common factor. So once again, yeah, see, you did grouping in pairs. Now you're going to take out the highest common factor, right? So you can take out x plus p, and what you'll be left with? 3x minus 2m. And that's it. Done. Okay, you can't factorize any further. 1.1.3 2p squared minus 2p minus 12. Right? Always look to remove the highest common factor first. What's the HCF here? The highest common factor is 2. You can take out 2 as a common factor, and what you'll be left with? P squared minus p minus 6. Double check. 2p times p is 2p squared. 2 times minus p is minus 2p. 2 times minus 6 is minus 12. What's this over here now, right? So you remove the highest common factor. Now this is a trinomial. It's a quadratic trinomial. So therefore, 2 into, what's p squared? P squared is p times p. What's the factors of 6? Factors of 6 is equal to 1, 2, 3, and 6. So look for any two factors. Now when you multiply together, it must give you minus 6. But when you add them together, it must give you minus 1, which is the coefficient of p. So let's have a look at that. Yeah, see, you can see there 2 and 3. What are the factors going to be? It's going to be positive 2 and negative 3. Why? Plus 2 times minus 3 is going to give you minus 6. Plus 2 added to minus 3 is going to give you minus 1. So therefore, it will be p plus 2 and p minus 3. Double check. See, you remove the highest common factor. P times p is p squared. Plus 2 times minus 3 is minus 6. There's the there. Plus 2p and minus 3p gives me minus p. And learners, that's how we factorize a trinomial. So we've covered all the different types of factorization in these two-part videos, part 1 and part 2. And you just need to keep on practicing. Learners, if you haven't subscribed already, subscribe to JL Maths. You can also like my Facebook page, Justin Lazarus Mathematics, and watch all videos in order of the work schedule on jlmaths.com. And I'll catch you in the next video.